We are going to be solving systems of inequalities. Notice here that I have, instead of having equal signs, I have a slope-intercept form with a less than or equal to symbol. I have a standard form with a greater than symbol. We're going to do this by hand. Before we do it by hand, though, I do want to jump over and let's look at what it looks like on Desmos. I also want to make sure you know how to put the symbols in. The symbol that we needed right here after the Y was the less than or equal to. So the less than or equal to symbol, you can use, of course, the keyboard that pops up right here, and it has the less than or equal to symbol. But I also want to show you that you can do it another way. If you just do the less than symbol, like if you use the one that's on your keyboard, you know, if you use that less than symbol, and then immediately after that you put an equal sign, you'll notice that right here it changed that to less than or equal to. So if you want to use the less than or greater than symbols that's on your keyboard, right after you type either one of those, you follow it with an equal sign. It puts the bar underneath it for you. So Desmos will graph inequalities for you. Turn this on right here and it graphed the line, and we're going to graph it by hand in just a second. It graphed a solid line. You see right here that it's solid, and it's shaded below. So it will do the shading for you. We've done this before. Now that we're going to graph a system, we know that, let me back up. So we know that every point that's in the shaded section right here is a solution to that inequality. You take any one of these points that are in the shaded section and you plug it in and you'll get a true statement. So you graph a second one on the same plane right here. Notice that here on the blue one we got a dotted line because this is greater than. We have shading above the line because it's greater than. And any point that is in this blue section right here will make this inequality true, the second inequality true. So how do you know where the solutions to the system are? In other words, I'm looking for the points that make both of the inequalities true. At the same time, it's going to be this section that's right here in the middle. The section where they're both shaded. It kind of looks a little purple here. You've got the pink part down here, you've got the blue part up here, and then you've got the purple part right there in the middle between the two lines. Those are the points that will make both equations true at the same time. So we're not going to do it exactly like this when we do it by hand. That's why I wanted to show you what Desmos looks like. We're going to only shade the section that's both. So let's jump over here and review doing it by hand. So you know that working with slope-intercept form, you start with the B, and you recognize the B is the number that's not with the X. It's the constant. So that's going to be where I put my dot on my Y-axis. This number right here is at +9, so I'm going to go to the Y-axis right there and put a dot at 9. So there's my dot. Okay, now I'm going to look at the number that is in front of the X, and I'm going to recognize that number is the slope. Let me make some notes here. So this number right here, this is my B. So B is 9, and then this number right here is my slope. My slope is always rise over run. And so I'm going to take that number, it's a negative, put the negative out in front. The number is actually a 1, so I put 1 over 1, because if it's not a fraction, we make it a fraction by putting 1 on the bottom. So this is going to be a negative slope. Since it's a negative slope, that means the line's going up on the left, it's going down on the right. So I'm going to rise 1, run 1 to the left. So from that dot right there, I'm going to rise 1. There's rise 1, I'm going to run 1, and there's my next dot. Now, if I had more graph paper, I would keep going, but I don't. So this time I'm going to go back to the 9. I'm going to go down 1, and I'm going to go to the right. And I'm going to keep doing that. Down 1 over 1, down 1 over 1, down 1 over 1, and I'm just going to keep doing that. I think I can do it with this too. Down 1 over 1, put a dot. No, it won't let me put a dot with my mouse. Anyway, so you just keep doing that over and over and over until you get enough points that you can feel like you can draw a straight line. I like to go from one edge of the graph paper to the other. It's really hard to draw this on this tablet. So there's that line. Now, it is a solid line because of the bar underneath it, and it does say, so this symbol right here is how I know I have a solid line, and it's also how I know I'm going to shade below. Now, I'm not really going to shade right now. I'm just going to kind of give myself a little hint that when I do shade, I'm going to be shading this direction, because that's what it means when I say I'm going to shade below the line. And I'll show you why I don't want to do a whole lot of shading. But I know if I needed to, I could shade all of this in over here. That's all below the line. But I know that I'm going to have another equation on here, and that second equation is going to give me a restriction on my shading. So I'm going to wait before I shade everything. So now I'm going to look at this equation that's in standard form, and with it being in standard form, I'm going to graph this one by finding the x and y intercepts. So I'm going to find the x-intercept first. I'm going to write down just the 2x. I'm going to go ahead and put an equal sign right there because I'm finding an x-intercept. So I'm just going to do the 2x. I plugged in 0 for y, that makes that be 0. So 2x equals 6, divide by 2, and my x-intercept is 3. That means on the x-axis, I'm going to put a dot right here at 3. Now I'm going to find the y-intercept by using just the y part. I'm going to go ahead and put an equal sign because I am finding the place where it crosses the y-axis, so I can use the equal sign. I'm going to solve for y and divide both sides by 3. That means my y-intercept is going to come out to be 2. So on the y-axis, I'm going to put a dot at 2. Okay, so I can see that to get from one dot to the other, I'm going to rise 2 and run 1, 2, 3. So if I want to do it again, I can get another dot. Rise 2, run 1, 2, 3. So I need a dot right there. Okay, and I can do it again. Rise 2, 1, 2, 3. So I need a dot right there. Okay, rise 2, 1, 2, 3. I can go back down to this side. I can go down 2 and over 3 this way. Okay, and go down 2, 1, 2, 3 this way. Now this line, when I draw it, is going to be a dotted line. It's a dotted line because I don't have a bar under the inequality, so it's a dotted line, and it's also greater than, so I'm going to shade above. Okay, so that means I'm going to shade this direction. Okay, so my shading, which I will do in a highlight, so it will be just the parts where both of these are shaded at the same time. So while if I didn't have this pink line right here graphed, if I didn't have the pink line graphed, my shading would be all of this, but I'm not. I'm only going to shade up to the pink line, and from the pink line, I'm going to shade down to the green line. So my shading is going to be this stuff that's in between those two lines, all the way up to any point that's on that line, because that's a solid line, all the way up to any point that's not, we don't include the ones that are on the dotted line because they will not make the equation true, the inequality true. But any point in between will make the system true. So you could pick any point that's in that shaded section, and when you plugged it in up here, what's the point? I just did the point 3,3. So we can check 3,3. You plug in 3 and get less than or equal to -3 plus 9. And then you plug in into the other equation as well. 2 times 3 plus 3 times 3 is greater than 6. Over here you get 3 is less than or equal to 6. That's a true statement. And right here we get 6 plus 9 is greater than 6. 6 plus 9 is 15. That's greater than 6. That's true. So we got a true statement in both cases.